All right, so any questions so far? All right, so I'm pushing code out to the code area on Canvas on the server, so we've got that. So let's go back to our rectangle class and let's get rid of these privates. Let's get rid of color. All right, so remember the basic setup, right? We've got a main class called main. It's got a public static void main method. We were constructing some rectangles using the new keyword, right? So rectangle is a class. R1 is an object. It's an object of type rectangle. It's an instance of a rectangle. So we construct it by saying new rect. And we can print out its length, for example. And so here's the simplified class rectangle. It has a height and it has, let me call this width because I don't know why I called it length. So a height and a width. I'm hearing voices. So I showed you can use aliases, right, to avoid typing stuff. So I also made a little setup file that sets up those aliases for me, so I don't have to type alias every time that I do this. So if I just say setup, if I just run this as a script, it's not going to do anything, because remember 224 scripts run in their own bash session, and when that session exits, my aliases will not be set up. So there's a command you can use, which is source, which says open that file, read in those lines, execute them from this current bash session. So if I say source setup, now I have some aliases for compiling and running. So that'll make things a little more efficient. Okay, so we can compile this up and run it, and it doesn't do anything. It shows us the width of the rectangle is 0. All right, so I've said that classes are kind of like structures in C, right? They let us take a bunch of variables and embody them in a single new type of variable, a rectangle in this case. The other thing that classes do that is different from structures, that goes beyond that, is you can also incorporate code. Okay, so let's put some code in here. So I'm going to make a public. And we're usually not going to use the word static, okay? You use static for public static void main, but in general, we're not going to use the word static until we get to like week 5 or 6 or something. So we're going to use the word public for everything because we want this to be accessible by things outside of this class. And then the rest of this is just like declaring a function in C. So I don't know, let's just do an integer. Integer, we'll call it double me, and we'll take an argument x. Okay, so there's a silly function. It takes an argument x, multiplies by 2, and returns its value. All right, so I have a rectangle R1. Let's set x equal to 20. And let's take R1 and let's call its double me method function. Pass x to it and take the result and call it y. So R1 is a rect, right? It's a class. It has fields called width and height. But it's also got a field which is a function called double me, right? And if I say name of a rectangle dot height, it gives me the value of this variable. If I say dot width, it gives me the value of this variable. If I say dot double me, it basically gives me the value of this function. Okay, it's just like another field in the class, but it happens to refer to a function, which could be a whole slew of code being executed. But to our main program, right, we're just saying go to R1, that's a rectangle, run the double me code. So this should set y equal to 40. Right, and you should be starting to appreciate that these are a little nicer print statements than the printfs that we've been doing, because I don't need the %d kind of stuff.
So why you don't need to plug S1 value?
Sorry?
Why you don't need to you got plus S plus and Y equal not?
I do need a plus. Thank you. Thanks. All right, so this will print out the values of x and y, and x should be 20 and y should be 40. So we'll compile that up and we'll run it, and no surprise, it works. All right. Well, that's interesting possibly, but it's not terribly useful yet. Because why do I need this double me function to be part of this class? Why don't I just write a function called double me like I do in C? Because double me is a silly function, okay? It has nothing to do with rectangles. And it has nothing to do with the particular rectangle R1. It's just a function that I thought might be useful to have. So let's get rid of that, because that's silly. Let's look at a more interesting function. Let's look at a function that tells us the area of a rectangle. Now, I could do this. And that would be how we'd write an area function in C. We pass it the length and the height of the rectangle, it multiplies them and returns the area to us. Yeah?
How do you decide between using an integer and a double?
I'm just doing doubles today because I might do some square roots.
Okay, so you used an int earlier.
Yeah, so I did it doubles yesterday morning and I did ints yesterday afternoon. Now I'm back to doubles. Doubles are real numbers, ints are just integers. So, but I'm probably going to want to find like the diagonal of a rectangle, and so I want to use doubles. All right, so I have an area function called area. Takes two dimensions, multiplies them, returns the product. So I could do the following. So let's give some dimensions to R1. So let's make R1 a 5 by 7 rectangle. So R1's height is 5, R1's width is 7. Okay, so I'm going to call the area function. I'm going to give it dimensions of 5 and 7. It's going to give me back the area. I'm going to print it out. It's going to be 35. This is still not terribly interesting. What would be a little more interesting here is instead of calling area with 5 and 7, right? Because I'm cheating. I know that the dimensions are 5 and 7. What I really want to do is call it with dimensions of r1.height and r1.width.
Wouldn't it, since the area is part of that class anyways, wouldn't it be best, couldn't you make it where you didn't need to give it the height and width, you just call area, and it would already know what area is made of?
Okay. Did everybody hear that? So we can do this, and this will work, and it'll give us 35, but since area is part of R1, and R1 already knows the height and width of R1, do we really need to pass those as arguments? And the answer is no. So just for completeness sake, right, we'll run that, we get 35. That's fine, but it's unnecessary. If we simply call the area function inside R1, R1 knows the height and the width. So now we can do something like this. We can make R1 have an area function that just takes no arguments, and what should it return? Height times width. So we compile and run, and there's your area. Okay, so let's go a little crazy. So let's make another rectangle R2. And let's just go right into some more powerful stuff. We don't need a temporary variable a equal to r1.area. Let's just print out r1.area. And then let's print out the area of R1 and the area of R2. Alright, so we run that, and R1's area is 35, R2's is 20, 200. So this starts to look a little cleaner than what we're doing in C, right? We don't have to pass around variables as much to these functions because most of these functions rely on variables that are already a part of the class. But the way this looks to a programmer is area, parentheses, parentheses, is just another field of this superstructure. This class called rect. It's got width, it's got height, it's got area. But it turns out when we call this area, when we try to get this area field, it runs a bunch of code. Right? And that code can use whatever is available in that class, or it could use things from outside the class. And it comes back and it just gives us a value. So this is encapsulation. Yes?
So for area, when that's, is that automatically created as soon as the structure is, or is that automatically created as soon as it's given the variables, and then is it stored, or is that calculated when you call area for the first time? Or is it just
It's executed every time that we need to do something with, rectangle.area, it executes that code.
Okay. So that can actually slow you down if you're doing
Yes,
multiple calls.
yes. And that can be a little squicky at first. And then you decide CPUs are fast, I don't care, and then you're free. And you just start making everything inside functions, and you use functions everywhere. And yeah, it's a performance hit, but it is so much more convenient. And once you drink the Kool-Aid, you'll never go back. All right, so so terminology, right? Functions in Java are called methods. I don't know why exactly, but this is the area method, right? The main program is called the main method. So method is just a word for function, okay? But it refers to something that is, you know, a function that's part of a class definition, for example. So this is a function with one method, which is called area. Right? And so if I change the height of R2 here and then I call the area method, I should get the new area, right? Which is going to be 7 times 20 should be 140. And my understanding of this rectangle class is that there's an area method that I can call anytime I want, and it'll give me the area of the rectangle based on the current height and width. And I could make a perimeter method that would return the perimeter, and I can make a diagonal method that tells me how long the diagonal is, and so on and so forth. Okay, well let's make a slightly weirder function. So here's a rectangle which is 2 by 8. Its area is 16. Here's another rectangle, which is 4 by 4, and its area is 16. And for any rectangle, we can always find a square with the same area. Okay, so we can call this squaring a rectangle. And it's easy to take any rectangle and square it, right? We take the area, we take the square root of the area, and we use that for the 2 dimensions. And so the width and the height are the same. When you multiply them, you'll get the square root of the area squared, which is the area. So we can square a rectangle, right, which is easier than squaring a circle, by the way. And maybe that's something that's important to us for whatever reason. So we can make a method which will square a rectangle for us. So let's do that. So this is not going to return anything. I'm going to call it square me. It's not going to need any arguments. So I need to calculate the area and take the square root. So there's a square root function built into what's called the math class, and we get to it by saying math dot square root. And then in here I can take the area, and now I can change the height to be equal to that, and I can change the width to be equal to that, and I don't have to return anything. I'll start saving this before I obliterate it. So let's give this thing dimensions of 2 by 8. All right, so what do we got here? We got R1 is a rectangle, we set it to be 2 by 8. And then we print out what the height and the width of the rectangle are. It should say 2 by 8. And then we print a message saying we're about to square all R1, and we call the square me method. We don't pass it anything, it doesn't return anything. But the square me method is going to look at the current height and width, find the area, take the square root, change the height and width to be equal to that.
Could you have called area?
Yes. Good. We're going to go back and change that in a minute. Excellent. All right, so this should turn a 2 by 8 into a 4 by 4. Syntax errors notwithstanding. Ignore all that. All right, so it was a 2 by 8, and now it's a 4 by 4. Okay, so key observation here, right? What did we want to do here? We wanted to set the length equal to the area of the rectangle. Well, we can multiply height and width, but we don't need to do that because we have an area function. So you can just say double length equals area. Now I don't want to say R1 dot area here because that would only give me the area of rectangle R1.
Do we want to do the square root of the area?
Yes, thanks. But if we just say area, it means the area method for whatever object we are currently using to reference this function, this method.
Does Java have libraries like C does?
Yeah, so it has
including-
packages.
You're including math
Yep.
in that class. Where does that come from?
We could say import, and we could put in a description of where math is, but math is always available. Strings are always available. A lot of these things are always available.
So if you were in a different IDE, would you have to like import those commands, or would they automatically?
Most environments, I think all environments, math is always available. String is always available. But for example, if we want to use hash tables, we have to say import something like java.util.hashtable or wherever it happens to be. And the Java documentation, the Oracle documentation, points you to all of that. And when we say system.out.println, that's like math.square root. It's println coming from something called system.out. All right, so this is the heart of object-oriented stuff. So two rectangles, R1 and R2. When I say R1.length, right, assuming I've said R1 equals new rect and so on, we kind of think of R1 as this thing, this object. And it's got a height, and it's got a width, and it's got an area method, and it's got a square me method. And R2 is another object, and it's got its own height and width and area and square me. Right? And it doesn't actually have its own copy of the code, but effectively we can think of it that way, right? It's got each of these things that make up the class. R1 has one of those associated with it. R2 has another one associated with it. And so we're safe inside here when we say something like math.square root area, right? If we used R1, right, if we said R1.square me down here, then when this code is executing, it's executing kind of inside that R1 object. which means that when we see the word height, it refers to the value of height inside R1. But if we had said instead R2 dot square me, then inside here height would refer to R2's height. Area would be R2's area, which is the same code, but inside that method, when it says take height and multiply by width, it's R2's height times R2's width. Right? So this is potentially a little quirky to wrap our brains around at first, but when it clicks, right, then it should make nice sense. All right, good so far? So, are you familiar with camel case? Snake case? Okay, so this thing I did with square me, that's called camel case. Methods, variables usually start with lowercase letters in Java. Classes start with uppercase. And you just kind of uppercase the first letter of words to make it easier to read. Snake case, you put an underscore, so it would be square underscore me. Camel case seems to be the convention in Java, but of course the compiler doesn't care. The compiler doesn't care if your class names start with lowercase letters. It's just convention. So I'll usually use camel case in here. All right, so let's get rid of this. This R1.height equals 2, R1.width equals 8. So we talked about private yesterday, and how we could actually hide some of these things like the height and the width. So let's do this. Let's make those private so that the outside class can't just come in and blindly start assigning values. For example, we really don't want height to be negative. Right? One, it doesn't make physical sense, but two, if we were to make the height negative and then ask for the area, we'd be trying to get the square root of a negative times a positive. That's going to blow up. And so we'd really like to make sure that height and width are not negative. We'd probably like to make sure they're bigger than 0, unless we define 0-dimensioned objects. But if we make those private, then we get all kinds of access errors from main saying you can't get to that. So here's the question. How can we have our main program set the height and the width when the height and the width are private?
Do you make like a temporary public, and then you use the public to parse it into the private one?
You could do that.
Create a function.
Or you could create a function, right? So a method. So this is the concept of accessors and mutators. So let's create some mutators. Setters and getters are the better alliterated way. So let's just write some methods for controlling the height and the width of a rectangle. So let's say r1.setHeight 2 and r1.setWidth 8. And to read the height and the width, we'll do the same thing. We'll say get height, get width. Those are accessors. All right, So now we don't need any direct access to the height and width fields. We're going to use methods. We're going to say get width or get height to read, and we're going to use set height or set width to set. I don't even know how you spell mutex or setters and getters. Alright, so public void set height double H. There you go. There's a method for setting the height. There's a method for setting the width. Yes?
So what's the point of setting it to private if you can access it through the setter and getter functions?
Because I can do the following. So I can make sure you don't set it to something negative. All right, and since we've made them private, we don't care if people read these, but we've made it private. You can't make it like read only. It's either private or public or protected. So we need a method to read these things. So there's a pair of accessors and mutators. And again, when you're using an IDE, you can click a button and it'll write those 4 functions for you for accessing and modifying private fields. Because we end up writing this stuff a lot. Let's see how many syntax errors. No syntax errors, there we go. So the original height was 2 by 8, and then we squared it and it became a 4 by 4. And if I tried to set the width to be a negative number, right, it'll ignore that because of our if statement, and it just leaves it as 2 by 8. All right, so questions up to here. Yeah.
Is Java that much slower? Because it seems like when you run it, it's like printing out, like you can kind of see it print, whereas in C it like dumps it out right away. You can't even see
That may be because I'm on the server,
Okay.
and last quarter I was always like on my own machine. It shouldn't be visibly slower, and the slowdown is shockingly small, it seems. Did you have a question, Jane? Okay. All right, so let's keep cleaning this up. Because every time I create a rectangle, probably one of the first things I want to do is assign a width and a height to it, right? Because a rectangle without dimensions, I'm not going to be able to do anything with it. So let's get rid of this. It would be cool if I could just do this. If I could just say, when you construct your rectangle, tell it what the dimensions are, and it'll go ahead and set those. And not surprisingly, that's an option. So we can make what's called a constructor. Because when we construct, we say rect R1 equals new rectangle, and I said that's kind of like a malloc. But we also have the option of not just allocating space for a rectangle and setting up those fields and so on, but also running some initialization code. Right? Something that we want to do when we construct a rectangle. And so that's something called a constructor. And a constructor looks like this. And the reason we know it's a constructor is because we did not specify a return type of variable. Any method that we write has to either return void, meaning it doesn't return anything, or an int, or a double, or something. But a constructor, we don't specify a return. And the name of the method is exactly the same as the name of the class, rectangle in this case. So that's going to make it a constructor. And that's all I need. So I'll pass the two arguments, h and w, and I'll just set the height and width equal to those. So compile that up and run it, and we're still where we were. We constructed a 2x8, and then we squared it and became a 4x4. But the construction took care of those dimensions. Now if I wanted to change those dimensions, do I reconstruct? Well, I could, but if I just want to change the dimensions, if I want to change it to be a 2x6, right, that's where I could say r1.setWidth, parentheses 6. If I were to actually reconstruct and say r1 equals new rectangle 2 comma 6, I'm creating a new object, right? I'm doing another malloc, and that's not necessarily something you want to do. So if new is kind of like malloc, what about free? What's the counterpart to free in C? What about memory leaks? And the answer is we don't have to worry about them. Okay, so there's something called a garbage collector that runs in the background of the JVM and looks for basically memory leaks, objects that no longer are accessible, and when it finds one, it'll basically free it for you. So that's kind of nice. Bless you. All right, ready to keep going? We're just plowing through like objects today. Well, sometimes we want to actually construct a square. A square is a rectangle, right? It's a rectangle that happens to have the same height and width. And so suppose we want to make a 5x5 square. I don't know what version we're up to. So suppose we wanted to construct a 5x5. And let's forget about squaring me. Okay, so I can say make a rectangle that's 5x5 and print out the dimensions of it. Or print out the area, right? So that's easy. But you know, if I want a 5x5 rectangle, do I really want to type in 5 comma 5? I'd really like to say I want a square, right? Which would be kind of nice if I could just say, just make a rectangle whose sides are length 5. And if I try to do this, as I've written things, it's going to complain. And it's saying the constructor rect in class rect cannot be applied to the required type. It's looking for a double followed by a double, and it found an integer. Well, if I had put a 5 period, it would say it found a double. But it's looking for 2 arguments, and I'm only passing 1. Okay, so actual and formal argument lists differ in length. Well, we can take care of that. I can make a second constructor. Still called rect, it's still public, doesn't return anything, but it takes a single argument, which I'm calling len, and it sets the height and the width equal to len. And if I do that, that's going to work fine. So when I said new rect 5, it set the height and the width equal to 5. But if R2 is a rectangle that I'm specifying both a height and a width for, that's also going to compile just fine, and it's going to run just fine. So what's happening here? I've got 2 constructors. They're both public, they're both called rect, but one of them takes a single double, the other takes 2 doubles. And you know, I could make a third constructor which doesn't take any arguments. And it's just going to set it to be a 1-by-1 rectangle. So if I just call rect and I don't give it any dimensions, I get a 1-by-1. So there's a few things going on here. The most interesting is that we have 3 functions with the same name. Yeah?
So can we write height equal y equal length?
Mm-hmm. Yep. Yeah, so we could have done height equals width equals len in that second one. So we have 3 functions, 3 constructors with the same name. Okay, so this is a concept called a signature. So in C, we identify a function by its name. If I have a function called area, anytime I say area, it's referring to that function. In Java, the identity of a function is more than just its name. It's its name plus the types of arguments that it expects. So I could also make a constructor that takes integer height and width. And I might do something different in this constructor. And that's going to be a different method from the one that takes a double and a double. So the signature is like the fingerprint of a function or a method. And it's not just the name, it's the name plus the types of arguments, which implicitly means it's also the number of arguments. And this is not just for constructors, this is for any function, any method that we write. So we can have multiple functions with the same name as long as they take different types of arguments. And that can be useful, because sometimes you want to do one thing if you're passed an integer, sometimes you want to do something different if you're passed a real number, and so on. Yeah?
And will the, what's it called, will it know if it's an int or double you pass it into it?
Yeah, so if it's a variable, it'll use the type of the variable. If you just use a number, it gets a little weird. If you say 5, that's an integer. If you say 5 with a period, that's a double. So numeric constants have sort of strange rules. All right. Other questions? So let's leave that there for now. Tomorrow I want to look at strings, which is a particular class, and we'll start looking at the fields and methods associated with the string class, and that will take us into something called a toString method. And then at that point, I think we've got everything we need to talk about PA1. So we'll talk about PA1 either starting tomorrow or definitely by Friday. All right, so see you next time.